بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're not going to take something new, but we're going to solve the problems concerning probability and conditional probability. Let's begin with the first problem. We have to remember P of A plus P of A bar is 1, P of A union B plus P of A intersection B is P of A plus P of B. The rule of conditional probability, the probability of A given B is the probability of A intersection B over the probability of B, and the rule of total probability, which is P of B, is P of B intersection A plus P of B intersection A bar. Now U and V are two ends such that U contains 5 black and 4 red balls. This is U. And then V contains 6 black and 3 red. And this is V. So we have two urns. One urn is selected randomly. So we have to select one urn randomly. Now pay attention here, the probability of selecting U is half and the probability of selecting V is half, because we have two urns and we need to select one of them randomly. If the selected urn is U, then 3 balls are selected randomly and simultaneously from it. And if the selected urn is V, then 3 balls are selected randomly and successively without replacement from it. Now we have to understand this story deeply in order to continue talking about the problem. In fact, we need to select one urn, either U or V. The probability of selecting U, as I said, is half, and the probability of selecting V is half. Let's say we had 3 urns U, V, and W. The probability of each one of them would be 1/3. Now, after selecting the urn, if it were U, we're going to select the 3 balls simultaneously from it. And if it were V, we're going to select the 3 balls successively without replacement from it. So the selection here depends on whether we've selected before U or V. Now notice here that we have two events happening. One of them is happening before the other. The first event is selecting the urn, and the second event is selecting balls from the urn. And from here we can say that this story involves conditional probability. Let's see the events. E, the selected urn is U, and R, the selected balls are red. Calculate P of E, P of R given E, and P of R intersection E. Let's go back to E. The selected urn is U. What is the probability of selecting U? It will be half because it's one urn out of 2. Now, what is the probability of R given E? Pay attention, this is a conditional probability. We have two events, one of them happened before the other. E happened before R, so we have to respect E. Let's see what does E state and try to apply it in order to find P of R. E states that the selected urn is U. And according to this story, if the selected urn is U, we're going to select the 3 balls simultaneously from U. So /E means that go to U and select 3 balls simultaneously from U. Now, how are we going to select these balls? In fact, this will tell us event R, the selected balls should be red. So this is U. Now we have U as the universe. We don't have U and V at the same time anymore. And the probability of R given E is the probability of selecting 3 red balls from U simultaneously, which is C34 over C39, which is 121. Now, what is the probability of R intersection E? We use here the rule of conditional probability. The probability of R intersection E is the probability of R given E times E, and we know both of them, and this is 1 over 40. Now let's continue. We're going to repeat the same procedure. We need to calculate the probability of R given E bar. This is also a conditional probability. E bar means the selected urn is not U, consequently it's V. So now we are working in urn V. Now, how do we select from earn V? According to the story, if the selected earn is V, we need to select three balls successively without replacement, and we need them all to be red. So it will be 3 to 1 over 987, which is 184. Now 3 to 1, because we have 3 red, then 2 red, then 1 red. This is a successive without replacement selection. Now, what is the probability of R intersection E bar? In a similar manner as the probability of R intersection E, this is the probability of R intersection E bar, which is the probability of R given E bar times E bar. We know R given E bar, which is 1 over 84, and we know E bar, which is 1 minus P of E, or directly, automatically, we can state that it's half. So this would be 1 over 168. Now, what is P of R? After knowing all of these probabilities, remember the formulas. Here we use the formula of total probability. What is P of R? It's the probability of R intersection E plus the probability of R intersection E bar. And we know both of them, and we get 5 over 168. Now calculate the probability of selecting 3 balls from NU knowing that they are red. Pay attention to the terminology, knowing that shows that we have a conditional probability. So let's translate this verbal expression into probability. This is going to be translated as the probability of E given R, which is the probability of E intersection R over P of R, which is 4 over 5. Now let's see another problem. Consider a fair cubic die numbered from 1 to 6 and two ends U and V. So we have a die and two ends. U contains 1 green, 4 blue, 3 red, and V contains 4 blue, 2 red, and 2 green. These are U and V. Now a game consists of rolling the die once. So we have to roll the die. This is the die. If the die shows 1 or 2, then 3 balls are randomly and simultaneously selected from U. Otherwise, 3 balls are randomly and simultaneously selected from V. So we have to roll the die first. After rolling the die, if we get 1 or 2, we will choose 3 balls simultaneously from U. And if we get a 3, 4, 5, 6, we're going to choose 3 balls simultaneously from V. So again, we have two events. One of them happened before the other. The first event is rolling the die. The second event is selecting 3 balls simultaneously from one end. If the die shows 1 or 2, we will choose NU. And if it shows 3, 4, 5, 6, we're going to use NV. Consider the events. A, the die shows 1 or 2. B, the 3 selected balls have the same color. Let's begin calculating these probabilities. Calculate the probability P of A. Now, what is the probability that the die shows 1 or 2? It will be 2 out of 6, because in this case, the outcomes are from 1 to 6, and I need 1 or 2, so they are going to be 2 outcomes out of 6 outcomes. Now verify that the probability of B given A is 5 over 56. This is again conditional probability. We have to respect A first. So the die shows 1 or 2, and according to the game, according to the story, if the die shows 1 or 2, we need to select 3 balls simultaneously from U. So by now our universe is U only. And from this new universe, we need to find the probability of B. We need to select 3 balls having the same color. Now, what are the 3 balls that have the same color here? They could be either 3 red or 3 blue. As you see, they cannot be green because we are selecting the balls simultaneously. So we get 3 out of 4 or 3 out of 3 over 3 out of 8. Which is 556. Now calculate the probability of A intersection B. After knowing the probability of A and the probability of B given A, we go back to the formula. the rule of conditional probability to get 5 over 168. Now, verify that the probability of B intersection A bar is 1 over 21. This is going to be done similarly. Here for the intersection we use the formula, and here for this intersection we also use the same formula. Let's see. First, I want to find the probability of B given A bar. A bar means the die doesn't show 1 or 2, so it shows 3, 4, 5, or 6. And in this case, according to the story, if it doesn't show 1 or 2, we have to select 3 balls simultaneously from V. So we know that V is the universe, and we need to select 3 balls having the same color from V simultaneously. In fact, here we cannot have more than one case, which is the probability of choosing 3 blue balls. So it will be 3 out of 4 over 3 out of 8. Now P of A bar is 1 minus P of A, which is 1 minus 2 over 6. Or we can see it also that we have 4 outcomes out of 6. Now we continue. What is P of B intersection A bar? It will be the probability of B given A bar times A bar. We know both of them. We get 1 over 21. Now calculate P of B. P of B is the probability of B intersection A plus B intersection A bar. This is the rule of total probability, and we know them all. We get 5 over 168 plus 1 over 21, which is 13 over 168. Now the last part, knowing that the selected balls have different colors, calculate the probability that the die shows a face with number greater than or equal to 3. This is also conditional probability. Pay attention because we have knowing that, and this is going to be translated into the probability of A bar given B bar. Let's see why. What do we mean by the selected balls have different colors? It means this is the complement of same color, so this would be B bar. And calculate the probability that the die shows a face with number greater than or equal to 3. Number greater than or equal to 3 means that the die doesn't show 1 or 2. Now, according to the formula, this is the probability of A bar intersection B bar over the probability of B bar. We try first to see whether we've calculated these probabilities before or not. Now, for P of B bar, this is 1 minus P of B. This is easy. And for A bar intersection B bar, we didn't calculate it before. That's why we use the total probability. This is the probability of A bar minus the probability of A bar intersection B, and we know all of these probabilities. We just substitute in order to get this answer.